Alright, so for this series, I'm going to be making an external for L4D2. This game does use Source Engine, so you should be able to follow along for CSGO or CS Source, or actually any game really, since externals are a bit more modular than internals. But anyways, some disclaimers first so you guys don't get the wrong impression of what I'm actually doing. First of all, notice how my game has the backend secure flag turned on, so make sure you put that in launch options so you don't get banned. Don't blame me if you forget, please. Second thing, I know this is going to make me lose some views, but if this is your first coding project, please just watch some other videos or courses first. Otherwise, it's going to be too confusing. Debugging is a big part of it, and if you're not too familiar with C++ or memory, it's going to be overwhelming. So I would suggest learning C++ first, maybe up until templates and overloading, and then try your hand in an internal first. Okay, last one. This isn't going to be something you can really copy and paste for source games. I'm not going to be using SDK or the league source code or anything like that. I'm literally going to make an external with no external information and just show you my process. Because of that, I'll probably run into issues during the videos while testing. If I don't notice at first, I'll probably just leave a comment with the fix, but don't expect perfect code. I feel like showing you perfect code with no issues doesn't help anyone if I don't show you the process. But anyways, let's set up the project first and then we'll try to find some pointers. So now we can just go ahead and make a project. So we're going to make a console application for now, but eventually we might just change this depending on how we want to draw the UI. There's usually two options. You can either make it a DLL to hook an overlay like NVIDIA or Discord or some other overlay and make your external calls from there. Or we could use the Windows API to make our own overlay. Probably make a poll for this in the Discord when it comes to this, but for now, a simple console application should work. So let's do that. Go L4D2. Now I'm going to change some settings or project settings because I don't really like the system that Visual Studio uses. I'd rather just use files instead of filters because I think it makes it a bit simpler. So here, show all files, add folder, one for source and one for build. Just going to change this to main for now and put this in source and make sure we actually change these directories. For the output directory, I want it to go into this build folder. I like this a bit better because if you were to post this on GitHub, you would just be able to copy the source and not have to worry about copying unnecessary Visual Studio files. And for intermediate directory, which is just object files, we're just going to do build intermediates, and the language standard, I'm going to be using CD20, and we can use C17 for this, for the C language standard. Obviously, this is just my preference. If you like the filter setup, you can use that. Doesn't really change the code at all, so go crazy, I guess. So I am going to take an object-oriented approach to this. So we're going to make a couple classes. We're going to have a memory handler, we're going to have an offset handler, and we'll probably have a main menu handler or menu handler. For the first one, it's going to be a memory handler. This is just going to handle all the operations related to memory, like reading, writing, attaching to the process, and getting module addresses. I like this approach because with externals, you can easily switch them to a kernel cheat by just changing the memory handler to make kernel calls. So write the cheat first as an external, and then you just change one class to a kernel. Memory handler, and we're gonna have another class. Oops, right-click the wrong folder, put that in source. And the class, we're gonna need some includes first. We're gonna need Windows. We're gonna also need TL help 32.h for some types. So set up public and private. For private, we're going to have two things. We're going to have the vword for the process ID. Process ID being, like if I were OpenSheet Engine, it would be this number right here. And we're going to have a handle to the process. Now, the way I'm setting this up is that we're going to be using external calls for all of this, but let's say you wanted to include some obfuscation to bypass some anti-cheats. All you have to do is change these functions directly. So this is going to be proc handles. I think that's the only privates we need for now. Let's make the constructor. Take a white string, constant wchar t pointer to proc name. And if you're not familiar with white string, you probably are. You just don't recognize it. It's when you pass a string like this. So this would be what we're passing into this function. And of course we need the deconstructor so we can close the handler when we close the external. We're gonna have an attach in case the game crashes or we wanna reattach without actually restarting the whole external. It's gonna take the same thing, the same argument as this. And we're also gonna have an SCD UIM pointer. That's gonna get the module address using the module name and we need C types for that. Now we're going to make some template functions for reading and writing. If you're not familiar with template functions, you're missing out. Basically, this function will write, actually let me write the function first, or declare it. So it's the first one is going to be read memory. It's going to take std uint pointer, address, and then we're also going to have write memory as well. So another template class, and it's going to be write memory, going to return a boolean, meaning if it's successful or not, and it's going to take the address as well, and the value that we're writing to. So now let's actually define these. So basically, the compiler is going to make all the functions, and it's going to replace this t with an integer, a boolean, a float, any other type you could be using. The compiler is going to make that function for you. And instead of writing all of those combinations, you just make a typing template function. Because the compiler doesn't necessarily know the types you could be using, this function usually doesn't have any autocomplete. So if you run into any issues building the project, it's probably in these two functions. We're going to need a temporary variable. We're going to call it read process memory. We're going to take the proc handle, which we either made ourselves or stole cast the address into an LPC void addr, the address of temp, what we're going to be writing to. We're going to pass the size of t, because we need to know how many bytes we're copying over to that new variable. And we're going to pass null pointer for the number of bytes read, since we don't really care about that. And we're just going to return temp. And we're going to do the same thing for write memory. Obviously, you could always define them directly in here, but I think it looks a bit nicer if you put them outside the class definition. So now we're going to do error checking for the write memory. So we're going to have a size t for bytes written. We're going to write process memory, proc handle again. We're going to, actually I'm just going to copy this first couple things. The address, we're going to pass the address of the value, the size of t, and the number of bytes written. And we're just going to return true if the number of bytes written is equal to the size of t. If they're different, that means there was an error somewhere, and this will be return false. Like I mentioned before, be very careful with writing these functions because you won't have any like red underlines or anything. So if you run into any issues, it's probably a typo somewhere here, which I'll probably have too. Okay, let's make these two functions, structure, attach, and get module address. Memory handler, it's pretty simple since we're just going to be calling attach. For the constructor, we're going to be closing the handle we made. If we made a handler, so close handle. If you don't close this, you'll have a bunch of open handles to the process and you might run into issues. Now let's actually make a handle to that process. Think of a handle as the operating system's way of giving a process access to another process. So depending on the permissions of the handle, determines what we can do with that other process. So there's permissions like read, write, which we'll need to read and write memory. There's create thread, close thread, and some others. This is one of the way anti-cheats protect games. They look for open handles to the game and check if they have suspicious permissions like read and write memory. But of course, there are legitimate handles that Windows uses, so they can't just outright block handles to their process. So you can technically hijack one of the Windows handles and use those to avoid some suspicions. But of course, this is just one of the things that anti-cheats also check for. So there's a lot more things you need to work around to make your own handle. For now, we're going to make it our own handle with all the permissions, but eventually we might change this function as well to use a hijacked handle. So the first thing we're going to do is we're going to take a snapshot of all the running processes on your computer so we can iterate through all of them and check if it matches the process name. And if it does, we're going to make a handle and attach the process. So we're going to make a snapshot. So let's create tool L4D2 snapshot, and it's going to take snap process for the flags and process ID null since we want to get all the processes. That's the plural. Now we're going to check if that snapshot is actually valid. So if snapshot is equal to invalid handle value, we're just going to throw an exception here because if we try iterating through it, we might run into some issues, crashing the game, or even other processes. And we need to include exception for this. Now we're going to define a new structure. It's going to be a process entry 32, which just stores the information about the process. We're going to set the process entry size to the size of PE. And just so you confuse, if you're ever confused about structures and you don't know what they actually mean, you can right click. I think it's peak definition somewhere in here and points to this. So we right click that again, peak definition. And here we go. So process entry structure will have the size, the usage, probably the CPU usage, the process ID, It's going to have the heap ID, the module ID, the number of threads, the process that created it, and some flags, and the exe path that executable. So right now, what we're looking for is we're going to be comparing the proc name we passed in and the exe file of that process. So for Left4 Dead, we're passing Left4 Dead 2 here, and the exe file is also named Left4 Dead. So that's what we're looking for. So now we're going to iterate through all the processes we found and check if we have a matching process. Process 32 first with your snapshot and the address of that PE we just made, and then we're going to iterate through all 32 next. Snapshot and the same thing. Now we're going to compare that those strings actually match, and we're going to use a function called wStringCompare because these are wide characters. We can't use string compare. We're going to compare the process we found. So pe.e, that's the exe file, executable file name, and the process name we passed in. Now we're checking if it's 0 because for this function, it returns 0 when the strings are matching, or when there's no difference. When there's a difference, it returns 1, which is a bit confusing. But okay, so now we're going to set the process ID. If we found a matching process, we're going to set the process ID to that PE process ID. So PE process ID, and we're going to set the process handle to the process we're about to make. Open process, we're going to pass process all access to have all the flags. But if we wanted to pass just read and write, for now we're going to do process all access. If you right click this, peek definition, there's a lot of flags you can pass. So we pass the process terminate flag, the process create to a flag. These are all the flags you can pass individually. So if you wanted to pass read and write, which is probably somewhere in here, and you can also check the Windows documentation for specifics on what these flags actually do. For now, we're just going to make a process handle that has access to everything. We're not going to inherit the handle from anything, so we're going to pass false since we're making our own handle. And the process ID is that process ID we just set. Now that we found the process, we're going to close the handle to that snapshot we made, and we're going to return because there's nothing else to do. If we didn't find a process, we're still going to close the handle again. We're going to throw another array, just copy and paste this, that just says, hey, we didn't find the process. Of course, you could use stdc out or any other things, but I like using std exceptions for externals. Now we only need one more function for the memory handler, and it's going to be get module base address. This is how we get those base addresses for those DLLs. Let me show you what that actually looks like. So if you were to go to memory view, go to view, and enumerate DLLs and symbols. These are all the symbols or modules that the game uses. They could either be libraries or DLLs, which are just dynamic libraries. So in here you would see things like OpenGL, WinSock, and there's probably client DLL, server DLL, and other source engine modules. What we want this function to do is it's going to take the name of the module we're looking for, and it's going to return this address right here. That way we can use pointers that start off with the base address of the module. So let's define this real quick. It's going to be very similar to attach function, as in we're going to take a snapshot, we're going to iterate through all the modules, and then we're going to check if we have a matching module. Just copy this for now and change the flags that we're passing to it. So for this, we're going to pass EH32 CS snap module. If we only pass snap module, we're only going to get x64 modules, but since we want 32-bit modules as well, we also need to pass the other one, which is the 32-bit version. So we can just copy this and paste it up. And we're passing the process ID. Now we're going to make a new module entry, entry 32. We're going to do the same thing we did before, set the size of that entry. Now we're going to copy and paste this because it's going to be very similar. Instead of process 32 first, it's going to be module entry, and we're going to do module 32 well. Copy and paste that. Instead of the exe file name, it's going to be the C module, and we're going to pass in the module name. So now, if we find what we're looking for, we're just going to break out of the loop to break. So if we found a matching one, we stop looping through it. We're going to close the handle, snapshot, of course, and we're going to return the std pointer that we need. So we're going to cast t pointer t. We're going to cast it to that mod base address. So by default, the entry mod base address in the structure is null. But if we find in this for loop, we're going to override it with the entry module and then cast it to an std uint pointer t definition. And again, it's very similar to the process entry. The module ID, the process ID that owns it, we have the size of the module, we have the base address, which is what we're looking for. As you can see, it's a byte pointer. We need to cast that to pointer that we can actually use. Okay, I think that's all we need for now. Later on, we'll probably add to this and save it just in case. Alright, so now let's actually try to find a pointer to the player class. Now for this, I'm going to be using two tools. Of course, there's Cheat Engine, which hopefully you've used before, and Reclass, which you might not be familiar with, and if you haven't used this, you're missing out. But we'll get to that when we get to that. So I'll make a single player map real quick, and please, I'm going to remind you again, use backend secure mode. I'm not sure if that's even on for single player games, but just in case, don't get banned for absolutely no reason. So I'm going to be trying to find the health, because usually that's in the player class. I wouldn't recommend trying to look for something like ammo or something related to the weapon, because that might be its own weapon class. So let me scan for 100 and then we take some damage. So we have 98 and 96, and I don't think we're going to get anything less than this. We're going to have to figure it out for these. So we're going to check for all these values, and we're going to check what writes to that address. So what instructions change our health. Hopefully we get something that could be, or looks like it could be, the player offset or the health offset from the player. That one seems it's using negative values, which doesn't make sense. This one's using 2E8, so we have 1 for 2E8. Let's check this one. This one's changing even though we're not taking damage. That's probably not that one. This one moved. We have C. But C looks too small for a game like Source Engine, so I'm not even going to try that. This one's moving even though we're not doing anything, so I'm just going to ignore it. This one's not changing. We might have to change to what accesses this address, but usually that's not as accurate. So we got one. It's coming from EDI and it's in server DLO, so this is probably not it either. This one also seems like nothing. And where are the zombies? This one looks like it could be some sort of entity list in the server DLO. We should take a look at that later, see if we can find the entity list for the zombies or the players. And let's try the last one before we give up on writing. Okay, and we're gonna have to use the other method. So let's start again. Let's do accesses, and we have the entity list stuff. We have some compares. EC, so that looks like it could be something we should be looking at. Keep that in mind. And it's in the client DLO, not in the server, so that seems promising. So I don't think the player pointer would be in the server DLO. This one has way too many. Another EC, so that's probably the health offset. Check this one, nothing. Nothing. Nothing, so let's just try one of these at the bottom. So we have a lot of instructions we could be looking at. They all seem to be using EDI. So EDI plus EC takes us to a health offset, then it gets dereferenced by these brackets, and it gives the value of the actual health. And I died. So let's look at EDI. Let's open reclass and put that in. And then for write, and we go to EC. it should be our health. We'll just not put the right address. I think I did. I did not put the right address. So EC should be our health now, which is 0. And I wonder if I can revive myself. So my health should be at 80 here. Can I change it to 100? Yep, so this is the right address to the health. Now we just need to find a pointer to this. So delete all of these, add an address, copy that, and paste that here. Now usually I try to find these manually, but if we get lucky, we can use a pointer scanner and save ourselves some trouble. When you're using the pointer scanner, I don't recommend you do anything more than 2. Anything else after that just is not as consistent. Replace the same one I always use, which is just a basic A dot pointer. No, wait for this to load. Alright, so we have a couple already. I'm going to sort them by base address, so it's a bit more easier to visualize. Now, usually, if the game has a lot of pointers, like client DLL, server.dll, engine DLL, I wouldn't recommend you try using pointers that start off with the base address of the exe. The player pointer is probably going to be either in the client DLL or the engine DLL. Alright, so I went ahead and restarted the game. Now we could just reattach. And we should be able to see more pointers. There's a lot of valid pointers. So we should be looking for one that's simple to dereference if we have options. So something around here that has 0. It's this one points to 3194 C30. So let me check that's actually valid, and if it is, we'll use that pointer. So we go reclass, reattach, put the pointer in there, and hopefully EC is our health. Alright, so now we can use this to actually make our offset handler. Like I mentioned before, I am going to be taking a class-based approach so we can make this as modular as possible and eventually switch this to a kernel cheat. So we're going to need a new class, and we're going to call it OffsetHandler. This is going to handle all the offsets, the player, the entities, and the module offsets as well. Put that back in there. This is going to need a few things. We're going to have a public, of course, and a private. In the private, we're going to have a client base because that's where the DLL is. Eventually, we're going to have to add more. For now, client base. We're going to have an entity pointer to a player, and we're going to have a memory handler pointer to the memory handler class. And so we don't have to include the memory handler each time we include it. We're going to forward declare it. So forward declaring will prevent every time we changed our offset handler header file, or every time we include the memory handler. It's going to prevent it from rebuilding this really big windows.h. It's going to make our building time much shorter. So we're going to forward declare the entity, which we haven't defined yet anywhere. We're going to forward declare the memory handler, and we need to include cstdent for the joint pointer t. So let me go to reclass and go to rename this to entity. I don't know why it changed again. Generate C++ code, copy all of this. We're not going to copy the static assert because we're not sure that it's exactly 440 bytes. I don't think that's supported in std20. Might be a different function for that. So we can just make a header file, call it generated code, just paste that in there. And we also need cstdent for the int32. Alright, so for the public, we're going to have obviously the constructor, the deconstructor, and we're going to have a function that calls read pointers. We're making this a function because we don't want to be reading every single frame of the game. Unlike internals that are really efficient because they're just dereferencing a pointer, in externals we have to copy over the memory from their memory space to our memory space. So imagine we're copying, what's the size of our class? 440 bytes. Every single frame. And if we add an entity list, so 440 times 16, 16 players, maybe more since we're using Left 4 Dead and it has zombies, the overhead starts stacking up really fast. So we're going to have a function that updates every couple of frames. And to get the actual player pointer, we're just going to have a setter and getter. We can just return entity pointer to the player and let's call it get local player. Obviously later on we'll have more offsets, but for now, since we're just testing that the memory handler works and the offset handler works, we're just going to have the client base, the player, and other requirements. So in here, we're going to have to include the memory handler. And this is one reason I named it memory handler and not just memory, because there's already a memory.h that we might use later. And if I had named it that, it would be really confusing to include it. And we're also going to need the generated code. So memory handler is going to be equal to new memory handler. And because it takes one parameter, that's going to be L, because it's a white string. And the name of the executable, not the game, because those are two different things. The window name that we see here is Left 4 Dead 2 DirectX 9. And the executable name that we're looking for is Left 4 Dead 2.exe. We're also going to make a new player, so player is equal to new entity, and I think I might have named it something different. It should be not capital. And we need the client base. The client base is going to be equal to the memory handler. We're going to get that with the get module base address, pass in another L again, and it's going to be client.dll. Now we just need to define the read pointers and the get local player function, which is just going to return the player. All right, so let's define the read pointer function real quick, and then we can test out our memory handler. So in here, we're going to have to read all our offsets. So for now, we just have one, but eventually this will rack up. So first, we need to get the player address. So we have to do uint pointer t, we do std here, and that's going to be equal to the memory handler. We're going to read memory. The type of the memory we're reading is going to be a uint, and the address of that memory we're reading is the client base plus the offset of the player. Let's make a define for that, yeah. So up here, let's make a new define. For now, let's just use defines, but later on we can have like a massive constant expression list or something like that. And the offset for that was 0x7c4450. And so this is going to give us the address of the player, but we need to dereference that. So we need to read the memory again. So now we just read the address of the player. Now we can use that address to actually copy the memory of that player class. So we can dereference our player. So dereference player is equal to memory handler, read memory, the entity, pass in the type, which is an entity, and it's going to take the player address. Now you might be wondering, why don't we just do this in one step and just do something like player is equal to entity pointer type and just read it directly. So like I mentioned before, our external and the game don't share the same memory space. So even if we were able to read the pointer directly, if we dereference that pointer, it's not going to point to anything we can access. So because of that, we need to access first the address of that pointer, and then we need to use that pointer to read the memory and copy it over to our memory space into this player pointer we declared. Of course, we could just do this entity player, but that would also include some overhead, because every time we get the local player, we would have to make a copy. And if you're wondering, why not just use a reference? Well, it's the exact same thing as a pointer. It's just the compiler dereferences it for you. So we're going to use a player. Anyways, let's finish the last function and the deconstructor, and we should be set to go. This is just going to return the player. And the offset handler is just going to delete all of those things we made. So it's going to delete the memory handler, so we don't have any memory leaks. It's going to delete the player, and I think that's it. Yep, perfect. Now here in our main, we're going to have a simple Menu just for testing. Of course, you could just use keybinds or whatever, but I'm just gonna print the health of the player to test that the memory handler works correctly. So OffsetHandler, OffsetHandler. Let's actually include those so I can use autocomplete. So we need OffsetHandler, and we need entity.h because that's not defined in the OffsetHandler because it's for declared in the header file. So we need to include that as well. Generate code.h. In the OffsetHandler, we're going to read the pointers, and then we're going to make a new entity pointer to player, and we're going to set that equal to the OffsetHandler get local player. And now we can just stdc out the health just to make sure everything works correctly. And I don't think I actually changed the name of the health. It's just the health. All right, so now let's look at our health. Our health at the moment is 100, so if we run this, we should be able to get 100 printed on the terminal. So we get that, and we have an error, I think. We have a crash, read access violation. There was probably a typo somewhere. So let's go to that. Let's see what we did wrong. Yeah, so I forgot to change everything back to where it should be after I was trying to explain why we couldn't read the pointer directly. So now if we run it, we should actually get 100. Let's try it out. And there we go. So everything works correctly. And I think I'm going to leave it at that for this video because it's already pretty long. For next one, I'll either find the entity list or we'll dissect the player class. Probably dissecting the player class. That seems like a smarter thing to do first. And maybe get a better pointer for this because I'm not sure if this is consistent. So if you guys find a better pointer that's consistent for all runs, let me know. But anyways, peace.